In this video, I will present a prototype of the 6.1850 implementation we have done. After a theoretical introduction, we will see a practical example. This drawing shows a typical 6.1850 installation. You have clients and servers. Both are connected through a 6.1850 network, which is called substation bus. The client can be the control center and is sending requests to the server. The server is generally called an IED, Intelligent Electronic Device. An IED, also called on this drawing logical device, can contain several functionalities. Each functionality is defined by the standard 6.1850 and it's called a logical node. Each logical node represents a physical device on the field. For example, a logical node can be a current transformer. It will be called a TCTR. A logical node can be a circuit breaker. It will be called the XCBR. Three layers are defined by the standard: the physical layer, the bay unit layer, and the substation layer. The ISaGRAF firmware with the server functionality can be used in each level. To define the hardware characteristics in ISaGRAF, we have a tool called Target Definition Builder, which allows to define all the properties of the hardware. In the case of 6.1850, we need to define the characteristics of all the logical nodes which will be used. For this, we have created a new tool, a new Target Definition Builder dedicated to 6.1850. This tool contains the definition of all the logical nodes defined by the standard, with the mandatory data and the optional data. You have to select the logical nodes you want to use, and for each of them, select the mandatory data and the optional data you want to use. Then, the definition file generated is imported into the workbench, and in the dictionary, some new data types are available to create variables. You have also to set an option for your device, is the support of the 6.1850. You are able also to create new function blocks and to use the structure defined for each logical node as inputs and outputs. Here are some examples of some function blocks using this structure of part of the structures. In this example, we have implemented a 6.1850 stack from Triangle MacroWorks, but any kind of stack can be used. In the workbench, we generate the target files, which is a tick code, and you generate an ICD file, which is downloaded in the server. In the controller, each part has its own data space. ISaGRAF has its own internal data space, and the server has its own 6.1850 data space. The link between the two data spaces is done by an ISaGRAF client. So, any 6.1850 client can connect to the server, read the ICD file to know what logical nodes have been programmed inside. Let's see now a practical example. In this case, I have programmed 5 bay. Each bay has some logical nodes. In this presentation, we will focus on bay number 3 with a current transformer and a circuit breaker. Here you can see the exchange of data I have programmed in the bay number 3. The current transformer is sending a value to the PIOC logical node, which is detecting another current. Then sending the information to the PTRC and CSWY to open the circuit breaker. I have also programmed an auto-reclosing logical node. In my example, I have programmed each logical node with one function block and use the element of each structure as input and output of the function blocks. Let me now show you how to use it. First of all, I will start the target definition builder we have done for 6.1850. I create a new file and I have the list of all the logical nodes. I will select these two ones and for each of them select or unselect the optional data I don't want to use. I will save the file, and as I am using a Windows target, I select the Win32 TGTL. I'm saving a txt file and I will call it test. I'm starting now my workbench and I want to import into the workbench this target definition. So I select the text file and import it. Okay, it's done. I will open my dictionary and I'm going to create a new variable. I will call it ISaGRAF1 and I will select as data type the IEC 6.1850 ISaGRAF. I can see that I have now for my variable a whole structure with all the data I have selected in my target definition file. I'm going now to open a new project where all the definition of the logical nodes corresponding to the example we have seen before are already imported. So in this project I have a program with all my function blocks and I have a dictionary with all the instance of the logical node I've used in my example. And in this program I have programmed all the functioning of B 2, 3, 4 and 5. I'm going now to download this project into my Windows firmware. So first of all I have to start my ISaGRAF firmware on my laptop. I'm going to build my project and download my project in my target. I see that ISAVM task has started and my 6.1850 server has started. I have downloaded the ECD file and I have downloaded the tick code. I'm going now online, so I connect to my ISaGRAF firmware and I will simulate the functioning. So first of all I close my circuit breaker and then I increase my current over 100 amps. I have a trip and I open my circuit breaker. I decrease my current, reset my default and close again my circuit breaker. Now I will activate the auto reclosing functionality. If I do the same, increase the current, open the circuit breaker, decrease the current, reset the default, and then the auto reclosing is started and the circuit breaker is automatically closed. Let's imagine now that 6.1850 client wants to connect to my ISaGRAF firmware and see the status of each data of my logical nodes. I'm going to start my IED scout and discover the ICD file I have on my target. I can see in my logical device that I have all the logical nodes that I have defined in my ISaGRAF project. If I compare my dictionary and if I compare what is seeing the 6.1850 client, I see that all the logical nodes appear. Let's try now to change some variables in ISaGRAF and read it with the 6.1850 client. So I open the TCTR3 and go to the amp and SMAG value. I change it in my ISaGRAF to 75. Go back in my client, read, and I read the correct value of my ISaGRAF variable. I can do the same with the XCBR3, actually closed. If I open my XCBR3 logical node, go in the BLK open, read, I see that it's false. So I'm going to increase the current. I open my circuit breaker, and if I read it again, I see that it's open. This was just a small example to illustrate the way the 6.1850 standard can be implemented into the ISaGRAF firmware. This video is now finished. If you want to contact us, write us at support@isagraf.com or support@isagraf.com.